Today, our panel is going to focus on space. Our moderator is Dr. Pete Worden, who graduated here from Michigan. I was hoping he'd show up at the Peach Mountain tour yesterday to help field all the astronomy questions. So if you have any lingering astronomy questions, find Dr. Worden. He's currently the NASA Ames Center Director and certainly a leader in where the U.S. is going with small spacecraft and space in general. So without further ado, I'd like to introduce Dr. Worden.
Thank you. See, I noticed they didn't put on my tag the year I graduated. It was 71, by the way. But I also think I didn't, embarrassing, I'm not an aerospace engineering grad. In fact, I know it's the 100th anniversary, but you guys are newcomers. I have an astronomy degree, and the astronomy program started here in 1843, so it... So when you get to 170 years, then call me back. But no, really, I'm really honored to be back here at Michigan. And in fact, 4 of the 5 of us here have Michigan degrees, and the 5th one has a Rutgers degree, which is a new Big Ten, school. Michigan will crush you. Okay, I'm known to be a troublemaker, so I'll do that. I'm really honored to introduce this panel, and there's 2 of us are government people, 3 of us are like make an honest living, and one of us used to work for the government until he made an honest living. But in some sense, I've worked for NASA for about 8.5 years now, and prior to that, I was a critic for about 30 years. And, I've talked to some of you, but this is a really interesting time. I think our space program is today kind of like the United Kingdom. We had a few disagreements, and there were some votes, and now we're kind of together again. And I'll tell you what I mean by that, because the people we have up here represent that togetherness. That the last couple of weeks have been phenomenal in terms of announcements and things moving forward with the private sector, with government systems, and so forth. We may disagree a little bit about the details, like we don't have enough money, but I think that our space program, our whole space program, our commercial space program, our military space program, and our NASA space program are really on a huge upswing, and I think you'll hear a lot about that today. And so I'm looking forward to hearing from the group here, because I think it's going to be fun. Let me just briefly introduce the folks, and then they'll come up here and talk. First speaker is Rob Meyerson. He's the CEO of Blue Origin, U of M grad. He worked at the Johnson Space Center for a while. I don't know, didn't you apply to Ames? You couldn't get in. That's. But at any rate, then his area of expertise is a lot in kind of things that re-enter. So a really great career, and Blue Origin, as you've read in the paper, has a lot of cool stuff going on, and I hope we'll hear a little bit about that. And then I have my colleague Lauri Hansen from the Johnson Space Center. She is the head of engineering at Johnson Space Center. She's worked on just about every one of the major programs that Johnson has, the International Space Station, Orion. She's had a big support for the Commercial Crew Program, also a University of Michigan grad. And I noted in the bio she has 3,000 people working for her, which is about 500 more than I do. So, if you like my job, you're welcome. The wine is better in California. But we're looking forward to hearing from her about a lot of the things that she's doing. Dustin Dowd from SpaceX is the manager of products and programs. SpaceX, you might have heard of lately. Interesting company, and also a University of Michigan grad. He's the youngest one of us. That was it 2005, I think? 2005, so go Blue. So we're looking forward to hearing from SpaceX. And last, but certainly not the least, is Frank Demauro from Orbital. He's done a lot of work on commercial spacecraft and launch vehicles, in managing programs such as the GeoStar 2. Really, really neat effort. And as I said, you know, if you can't go to Michigan, go to a Big Ten school. So now Rutgers is one. So again, we'd like to thank him. A couple questions to keep in mind, and we're going to let each of these folks talk for about 5-10 minutes. Some of them have videos to show. But the key things I'd like people to think and keep in their mind is, what's the future of manned flight? What's the future of reusable spacecraft? A particular issue for all of us is, what's the role of our collaborations with foreign partners? The U.S. is no longer, you know, unique in the world in space. And finally, the role of space entrepreneurship. And I can tell you the last one is a real challenge. I hired a bunch of young people, including Michigan grads, and they all do startups. So that's a pretty big issue. It's also a big opportunity. So without further ado, I would like to introduce Rob Meyerson. Yep.
I'm going to give an update on Blue Origin. I've been with Blue Origin since 2003. I started my career at the Johnson Space Center and then went to Cutler Aerospace after that. So I've been in this commercial industry since 1997. I'm still very excited about it, about the potential and where we're going. If we can go to the first chart, I'll give you a little background on Blue Origin. First off, the name, Blue Origin, means the Earth is blue, the blue marble. So someday in the future, when we're exploring the planets, blue will be our origin. It'll be the place we came from. So it's really Jeff Bezos, who's the founder of Blue Origin and our sole funder, and is his leadership there and his thoughts about this are such long-term, 20, 30-year time horizon, as opposed to what's the next government contract we can go win. This is really a long-term venture that we're in. We've been in it for 10 years and we'll be in it for a lot longer. So the focus at Blue Origin is on enabling a human presence in space by lowering cost. In our focus there architecturally is reusability, and we focused in on vertical takeoff, vertical powered landing as the means to get there. We have a saying on gradatum ferociter, that's our philosophy, and that means step by step ferociously. So we're doing things incrementally but with a bold vision. Putting humans into space without the government, without a large government contract is, I think, a bold vision. I think we can all agree on that. So we do development in-house, significant design, development, analysis, test, primarily in 2 sites. Our primary site's in Kent, Washington. We have about 300 people at that site, engineers, business folks, some legal, but primarily an engineering-driven company. And then we have a private, the world's only privately owned and operated launch site out of West Texas. It's 2 hours east of El Paso, Texas. It's on a private ranch owned by Jeff Bezos. And Jeff is, we operate that site. We've flown several demonstrator vehicles, vertical takeoff, vertical powered landing vehicles, and then we operate several rocket engine test sites, and I'll talk a little bit about that. Let's go to the next chart. And our incremental development plan includes starting with suborbital. We believe suborbital is the first entry that's going to give us an opportunity to open up a very, very large market, not 6 to 10 flights a year to the International Space Station or launching commercial satellites, but launching people like you that want to fly themselves or they want to fly space payloads and technologies. We believe that has the potential to open up broader markets, and it gives us the potential to gain valuable experience in operating these cryogenic reusable launch vehicles so that we can apply that experience to the orbital launch vehicles that we'll build next. We're focused on engine technology, and I'll talk about that next. But I want to show a couple of videos. These videos are on our website. We're the quiet company. We don't talk much, so you may not have heard of us. But I'll show these, and then you can go to our website later, and you can look at these as well. So let's see. Did you open the file that was in the folder? Okay. We just tested it. I'll encourage you to go to blueorigin.com. There's in our media page, there's a number of websites, a number of videos that show launch and landing of our suborbital vehicles, as well as a pad escape test, which we demonstrated in 2012. It was a demonstration of a center-mounted solid rocket motor with a thrust vector control system that we designed and built in-house and demonstrated the pad escape from a future human-rated suborbital vehicle. Our orbital transportation vehicle is going to make use of the technologies we demonstrate in suborbital. So the vertical takeoff, vertical landing technology, we expect our first stage to be vertical powered landing and fully reusable. This will lead to lower cost, which will, as we fly more, it'll lead to lower cost and higher reliability over time so that we can offer that to customers. And in the future, again, thinking long term, we think those 10 to 12 launches a year become hundreds of launches as we become a multi-planetary species and we're flying to low Earth orbit on a regular basis, unlike what we've been doing now. Let's go to the next chart. This chart shows the family of rocket engines that Blue Origin's developed. To develop a vertical powered landing system, we need rocket engines that are reliable, low cost, and can deep throttle. And so we put a lot of investment internally into rocket engines. BE is Blue Engine, and we have a family BE 1, 2, 3, and 4. The first two were developed using hydrogen peroxide, 90% hydrogen peroxide. So the peroxide you might have in your medicine cabinet is 3%. 90% is highly concentrated in an oxidizer that's used in a very storable propellant. We've developed a lot of technology in that area, and now lately we've been focusing on LOX hydrogen and now LOX liquefied natural gas. Sorry, if you can back up one chart. The BE3 is a 110,000-pound LOX hydrogen booster engine that we are designing. Its first application will fly our New Shepard suborbital rocket vehicle. It's capable of throttling down smoothly from 110,000 pounds all the way down to 20,000 pounds of thrust. We built that engine in-house, the turbo pumps, the valves, the main combustor. We have tested over 15,000 seconds of test time at our launch, at our test stand in West Texas. We also tested components of that engine at NASA Stennis as part of the commercial crew phase that we were involved in back in 2012. The BE3 is on the verge of being qualified for the suborbital missions, and our next use for that will be as an upper stage engine for our orbital launch vehicle. So we've already have the team started designing what we call the BE3U. It's a 150,000-pound thrust LOX hydrogen engine. It gains that thrust through the configuration and higher ISP through a larger nozzle, and that'll fly as an upper stage on future orbital launch vehicles. The BE4 is an engine we just announced on Wednesday, and I'm really excited about. We entered into a partnership with the United Launch Alliance to study the use or to develop the BE4 as a future booster engine for the next generation. It may be Atlas, maybe Delta, or they may name it something else, but the next launch vehicle that the United Launch Alliance builds, and you may know ULA is a joint venture between Boeing and Lockheed Martin. They launch national security payloads for the U.S. government and have a string of 88 successful launches. The BE4 is a 550,000-pound thrust engine that uses LOX and liquefied natural gas. Liquefied natural gas is commercially available methane, 95+% methane. It's an ox-rich stage combustion cycle. We are designing and building that engine in-house. We're 3 years into the development, have commissioned our critical test facilities down in West Texas to test this engine. We've developed the combustor at subscale. We worked with another Big Ten university, Purdue, on the single element testing for that injector. And our power pack, the power pack is the combination of the main turbo pump, the boost pump, the pre-burner, and the main valves. That hardware will go on the stand in October of this year. We'll start to test that critical part of the engine to buy down the major risks for BE4 development. We expect to get into full engine testing in 2016 and deliver those to ULA by the end of 2017. So we're very excited about that announcement. Next chart is just a summary. Really just a big thank you. Blue's been in business for a while. We're going to be in business for a long time. We are excited about competing in this industry, and we're also hiring. So Mr. Karam, we're competing with you as well. So we are, go to blueorigin.com. We have opportunities open, and I want to thank you for your time, and I look forward to your questions. So.
See, I think I have to adjust the mic down a little bit. So first, thank you for having me. Thanks to Dan and Jamie in particular. But it's really an honor to be back. As Pete mentioned, I was an aerospace engineering grad in '85. I was 12. Maybe not really, but it's neat to be back. I hadn't been back in quite a few years, and Central Campus doesn't look that different. North Campus looks really, really different. I think the only engineering buildings at the time were the AERO building and the Atmospheric and Oceanic Sciences building were there when I was there, and that's it. So nice to be back, and nice for you guys to arrange such wonderful weather. What I wanted to do today was talk a little bit about what we do at Johnson Space Center. And the discussion is, this whole panel is on the future of manned spaceflight. And that's really our emphasis. Many of you are very familiar with NASA, some not so much. The different centers have different emphases. Johnson Space Center is about human spaceflight. And engineering is about design and development of human spacecraft. And so I'm lucky enough to be able to work on the current human spacecraft we have on orbit, the International Space Station. We are over 5,000 days of continuous operations, a multitude of crews, and phenomenal science coming out of there. Also working on the development of new spacecraft in partnership with our commercial providers, which you'll hear quite a bit more about today, for low Earth orbit, and then for the government spacecraft, the Orion spacecraft, which will take us further than we've ever been, 24,000 miles beyond the moon, and then even more so working the technologies that will eventually enable us to put boots on Mars. So what I wanted to start with was a short video. Hopefully we'll do better with the videos, but start you with a short video showing sort of the breadth of what we're working on and talk a little bit about where we're going in the future. So actually, one of our younger engineers, who is also a Michigan grad, helped do the edits on the video, and she sent it to me, and she said, check out the music at the end, you're really going to like it. So she had a lot of fun with that. But if we can go ahead and go to the slide, really what that shows you is sort of the breadth of what we're working on. And I wanted to talk mostly today about where we're going, which is the commercial spacecraft. I'm going to leave that primarily for my co-panelists. And then the Orion spacecraft and on to Mars. So there was a lot of talk. You have to have been totally uninterested in space not to have heard all the talk after 2010 when the Constellation program was canceled and the shuttle stopped flying that, oh, NASA was going out of business and that was it for human spaceflight. And I would say actually just the opposite. Right now, where we're at is we're really trying to commercialize low Earth orbit. And when I talk to some audiences, I draw the parallel to the aeronautics industry. And so I remember clearly, I'm old enough to remember clearly my first flight on an airplane. And I was about 7 years old, and we were going to the West Coast, and it was a big deal. And I look at my kids have absolutely zero recollection of their first flight because they have flown literally all their lives. And you look at the time span that change has occurred in, and it's incredible. It is an incredible difference between when getting on an airplane was a dangerous thing that few people did to, wow, I want to go visit grandma on the other side of the country or on the other side of the world. So that's the goal for commercializing human spaceflight in low Earth orbit. It's in its infancy, but there's lots of really exciting efforts to try to commercialize that. Then beyond that, what NASA's really concentrating on is pushing to the next level, pushing beyond low Earth orbit, beyond where Space Station is today, past the moon. So the next mission that we're looking at is the asteroid redirect mission. A lot of proponents in the press, a lot of opponents in the press. The context that I would put it in is it's a proving ground. We are unfortunately not ready today to send a human mission to Mars. It's a 3-year round trip. There are lots and lots of technical challenges, biological challenges. There's a little thing called money, which is a challenge. But what we really do need to do is prove that we can sustain human spaceflight exploration beyond low Earth orbit. And to give you a little bit of a feel for that, we have the space station in orbit 365 days a year. If something goes wrong, we send up spare parts. If something really went wrong, they have a lifeboat and they can come home. That's not an option when you're on the other side of the moon. If your water supply isn't pure, you're dead. If your environmental control system doesn't remove your CO2, you're dead. So it's a very different set of problems, same set of problems, different set of consequences and different ways of dealing with it. So what the asteroid redirect mission is about is a means to an end. Yes, it's cool to be able to redirect an asteroid and send a crew to it and get samples and send the Orion spacecraft there. But really, it's a stepping stone to a much larger endeavor, which says we really want to put human boots on Mars. And we really want to do it relatively soon. So that's the emphasis that we're working on right now with the Orion spacecraft. Its next mission is slotted to go into a distant retrograde orbit around the moon, sort of a fancy term for a really, really big lunar orbit. It does, at its furthest point, go about 24,000 miles out. It will be on top of the Space Launch System, the big rocket that's being developed at Marshall, and should be the next big proving ground for our further exploration to Mars. And what you also saw at the end of the video was a lot of the technologies that are required to make human spaceflight to Mars really a possibility. One of the things you saw was robotics, which is kind of interesting because people think human spaceflight or robotics. And I would say that's ridiculous. It's human spaceflight and robotics. If we send people to Mars, it's a 3-year round trip. They would probably be on the surface for about a year. So you have to pre-position habitats. And you have those pesky things called launch windows, which means you have to have pre-positioned them well in advance. And something has to maintain it. So things like robotics and automation are crucial to being able to keep the people alive when we get them there. So that's our next step. And we really hope that, that many of the students in the audience will be involved in helping us make that step and can watch us put the first footprint on Mars. Thank you.
Hi, everybody. My name is Dustin Dowd, and I am what you'd call not your first panelist choice for this panel. But I'm happy to be here. And actually, it's interesting. I have pitched to both Pete and Frank as part of my career. To Frank, when I was an employee at Orbital, back before Michigan had a CubeSat program, I graduated and started at Orbital Sciences. And then Jamie Cutler came along and needed to test the GPS on the RAX satellite. And I knew students working in the lab, and I knew we had a critical, very expensive piece of GPS simulating hardware. And so one of my things that I did was I pitched to Frank that we should go ahead and let Michigan use this rack for free. And he let us. So so when I was the, I don't know, 5th or so name that came up for this panel, I was happy to see Frank's because I wanted to bring that up. It was pretty cool. And I've pitched to Pete 2 at Ames, but he hasn't said yes yet. So I'm.
Has to do with money.
Yeah.
Lauri talked about that.
So I've been at SpaceX for about 5 years now. I did not have a presentation, but I did bring a video that we can, if you play now, please, I can just kind of talk over it. One of the subjects that we're going to talk about in the panel is the advent or the emergence of reusability in spaceflight. And the video that I brought along is one that you may have seen before, but it's our I think it was the last flight of the Grasshopper. And our Grasshopper is a test vehicle based off of a Falcon 9 first stage. Has one engine and legs that are kind of fixed in deployment. But you'll see when the video starts here. There we go. So this is a cam-looking nadir, and you're going to see it take off. Those legs are the little cross check mark in the background. And here we're taking off. This is our Texas facility. Texas is a great place to test rockets, as you may have gathered. So we're taking off. And this is the first flight of, we had done flights with legs before on this test vehicle, but this is the first time you're going to see these little fins deploy on the top side of the vehicle. And we can actually use that to control the vehicle and land in a precise way. So this is really great. But anyway, so this is, I wanted to show this video in particular because it was a critical part of our panel, and also it's a critical goal of SpaceX to make launch and access to space something that is less exotic, more akin to air travel. And right now, it is super exotic. I was the program manager for the OrbCom program, which launched in July, and that delivered 6 spacecraft to orbit. SpaceX's first constellation mission, actually. And it was heroic. I mean, we were on the pad. We had some delays, but eventually we did it. We got it off, and it was flawless. But things like this, will hopefully be folded into that flight vehicle and kind of make your satellite delivery or anyone's satellite delivery just kind of something you go to the airport for. So this is going to land and then it's going to take off again. It's not another takeoff, it's another camera view. But there's some humorous cows in the next one, so stand by for that. And then we can cut it because I'll be done before this is over. But SpaceX now, I think one of the original. Well, it started in 2010 after about 5 years at Orbital, and now there at SpaceX for almost 5 years. We've got about 4,000 employees now, and see, look at that. It looks fake, but it's not. I'm amazed. So now we've got about 4,000 folks, and we've launched. Here, now check this out. Once the sound hits the cows, there they go. We've launched Falcon 9 several times. All have been a success. My mission was super exciting to be a part of. Since then, we've launched both AsiaSat missions, 6 and 8, and we have a launch early, or I guess technically Sunday, but if you're on the West Coast, it's really late Saturday, tomorrow. And everything is looking good for that, aside from the weather, which is at about 50%. So that's all I've got. I'm happy to answer your questions when we get to that time. What's that? So that's actually our ceiling, near our ceiling in Texas. That's a kilometer up.
But you're going to space station Saturday.
That's right. Yep, and we're launching the ISS on Saturday they actually just completed the late load cargo load, and we're ready to go. So looking forward to that. So I'll look forward to the panel and then questions afterwards. Thanks.
Okay, well, good afternoon to everybody. The warmest greetings from Rutgers University. I think it's October 4th, Pete? Yep. Rutgers Stadium. Be there. If the Rutgers quarterback throws directly to the defense like they did against Penn State, you guys should have no problem at all. Don't worry about it. 5 times. I'm in the audience sitting next to a Penn State guy, and Penn State's really obnoxious, but it's okay. The second thing is, talk about karma. I am really glad I let Dustin do that experiment now, because imagine if he said, I asked Frank to do that, and he said no. I might have to worry about that, but I'm thrilled to be here. Really excited and honored to have been invited. The hospitality has been tremendous. I've got a few slides, or maybe more than a few, but I'll go through them quickly in a short video. But we're going to talk a little bit about Orbital Sciences Corporation. I've been there almost 23 years now, after spending a few years at General Electric in the early or late 80s, early 90s. And as Pete said, I've spent a good portion of my career in commercial space. I did a little bit of time on the GPS work and DMSP for any of those that work with the Air Force spacecraft. Most of it has been in commercial for geosynchronous spacecraft, for commercial science spacecraft with NASA, actually, partnership with NASA. And then I've spent the past 5 years of my career managing the CRS program, which has been a phenomenal experience. So I don't know if this works. Maybe it doesn't. It does. So real quickly, Orbital's been around about 32 years. It was started by 3 people, one of which is named Dave Thompson, who's still the CEO of the company. And Orbital's focus initially was, and still is, to give commercial access to space for those who would like it. Early products include the Pegasus launch vehicle that drops originally from a B-52 and then from an L-1011. And we've developed commercial spacecraft along the way. As I mentioned, geospacecraft and the Cygnus spacecraft. We have about 3,500 employees. As most people may know, we're in the process of going through a merger with ATK, so that'll triple in size at some point, maybe by the end of the year. But Orbital has grown pretty quickly over the 32 years. We have lots of customers and lots of different types of customers. NASA obviously being our biggest customer right now, but a lot of commercial communication spacecraft customers, other NASA centers. We're proud of that because it says we appeal to a broad range of customers. And I think that's a good place to be. We do launch vehicles, we do satellites and space systems, we do missile defense work. The advanced space programs is what the CRS program was developed under and has remained under as a business area. But Cygnus, without a doubt, has been our most complicated development in our history. And so when it worked, which was great, there was much elation, and you'll see that in the video. We have facilities. Our headquarters is in Dulles, Virginia. We have a facility in Gilbert and Chandler, Arizona. We have offices in Houston and Los Angeles. And Greenbelt is where we do our servicing contract, mainly with Goddard. So we're spread around the country in several states. With ATK, it's going to be probably about half the U.S. But Antares is a rocket that was developed. Actually, we began the development of Antares in advance of winning the COTS Space Act Agreement. If you recall, originally the Space Act Agreement was given to SpaceX and rocket plane Cutler, and then due to some issues, rocket plane Cutler dropped out, and then Orbital won the competition for the remaining amount of work. Well, Antares had actually started ahead of that, and it was built as a medium replacement for medium-sized rockets, and eventually became obviously the rocket for the CRS contract. Cygnus, we've flown now 3 times. Our 4th one is coming up in October. I know SpaceX 4 is going Saturday, and then Orbital will go after that. We have 2 different versions. We've only flown so far. The one on the left, what we call the standard Cygnus, and then the one on the right is our enhanced Cygnus. And you can see big changes include the different solar arrays, very similar to the Orion arrays, and then the longer cargo module. So with the one on the right, we had planned to deliver about 2,000 kilograms of cargo per mission. On this next mission, we'll actually deliver 2,300. NASA said, more cargo, Lauri, and we said, okay. And so we stuffed more in there. And then for the enhanced mission, we'll get about 2,700 kilograms of cargo. And I just got a few pictures from our last mission, our liftoff of Antares from Wallops. This is very interesting. Dustin showed the film of the cows running away. Interestingly, when our last launch on Wallops, we actually have a similar video. There's a lot of cow pastures in Wallops Island. That's about it. That's all that's there. And we see these cows running away, and I think the cow lobby is going to be upset with us. We better figure out a response to that.
Another area for collaboration.
Collaboration, that's right. So Antares did very well again, and then we were eventually grappled. One of the great things about this, as I've said to many people, I've been privileged to be on a lot of spacecraft that have launched into space, but I had never actually seen it after it's launched. And this one came back, and it looked just like we sent it. And I said, that's a good thing. The decals stayed on, which was good. This was new. I had to convince Dave Thompson that they wouldn't come off and cover the star tracker and end the mission, and he said, okay. Anyway, grappled really well, and then about a month later, they let us go, and we actually re-enter and burn up in the atmosphere. On Orb 2, we did a special thing where we phased our re-entry right under the ISS, and so we got some cool video and pictures of Cygnus breaking up and burning up, and it's actually quite of an emotional thing. You see your little spacecraft burning up, but that's what it's designed to do with all of the disposal cargo NASA had put in it. But as Lauri talked about, and Dustin alluded to, and Ron, we're pushing to the future. We designed Cygnus to be a cargo delivery craft for what NASA asked us to build it for. But it has a lot of heritage and other things Orbital has done. It has a long life. It has a lot of fuel. And so we know it can do a lot of things more than we were saying it can do. There's a great line in Apollo 13. I don't know if it's real, but it's meaningful when Gene Kranz's character says, I'm not interested in what it was designed to do. I'm interested in what it can do. And so we're trying to push Cygnus to do what it can do. And so one of the things we think it can do is become a support craft for exploration, and for the exploration missions NASA is envisioning. And so some of the stuff we're really doing, for instance, on our Orb 5, 6, and 7 mission, we have a contract with NASA Glenn, and they're putting something called Sapphire. It's essentially a combustion experiment that they want to fly. They want to test more combustion stuff in space. We'll fly it up as cargo, and then it will stay in the module, leave, and we'll fly around for a few weeks as they fire off this combustion experiment, and they'll take the data, we'll downlink it, and then we'll re-enter the atmosphere. So that's a stepping stone to other things, and I won't read the words on the chart, but what we're really looking to do is look for ways that Cygnus can support NASA's efforts to go out deeper into space, beyond low Earth orbit. We can become a habitat. We can test out eclipse experiments. We can be a storage depot. So there are a lot of things that we think it can do with a little bit more development and a little bit more time. And we think as a commercially based company who uses commercial but safe practices, we think we can get there. And lastly, the Orion folks take note. I mean, fits perfectly. So, you know, I'll be here afterward if you have any contracts you want to negotiate for the use of Cygnus. For the, no, we think it has a lot of use, and hopefully we can do that with NASA. Last thing I want to do is just show a quick video. This is just our demonstration mission up and down. It's not very long. I just love to show it, so if we can. This is a year ago. Wow, a year ago yesterday. Time flies. So we launch out of Wallops Island in the eastern shore of Virginia. It's just a little bit below the Maryland-Virginia line. Wallops has been there as a launch facility for a long time, but not liquid facility. And so we developed the launch pad with the state of Virginia and Wallops, including a lot of facilities. Here's where the stage 1 will separate from the stage 2. It's a liquid stage 1 and a solid stage 2. The second stage on this mission is a Castor 30. On this next mission, it'll be a Castor 30 XL. You can see Cygnus separating from the launch vehicle there. This is the first and only vehicle without the decals. So that's why you know it was the demo mission. And here's as it approached and was eventually grappled. You can play the music. That's okay. And here's, as we're approaching, this is what the crew members will see as we're approaching. It needs to stay in that box. The crew member has at any time the ability to press a button and we will fly away. And here's the eventual grapple of the spacecraft. This is taken by, that last video was taken by a rocket cam we have on the spacecraft. And so we can downlink those videos and check things out from there. On this mission, we carried about 700 kilograms. It was a demonstration mission, so NASA didn't put a lot of critical cargo on there. But the latest missions, there's me in the back clapping, and what they cut off here is me going and hugging the mission director. I'm not too proud to say I was hugging everybody, I think, that day. And there's the birthing of Cygnus and the opening of the hatch by the crew, and that was holding our breath there as well. We wanted to make sure the cargo wasn't just flopping around the vehicle, but it wasn't. It was right where we placed it, and they started unloading it and eventually loaded it with a good bit of disposal trash. And then we flew away and burned up in the atmosphere, which you'll see in a minute. This mission was dedicated to Dave Lowe, a former NASA astronaut, a former orbital employee. He really pushed us to get into human spaceflight, and unfortunately passed away way too early due to cancer. But we dedicated the mission to him. And I'm glad it worked out so well for him. And you'll see Karen Nyberg coming out of the module after she put his picture in the module. The one thing I will say about Cygnus and all the things we're doing here and talking about, and I know exactly why we talked about the means, this being a means to an end. And I think one of the things I'd like you guys to think about is we really want this to be a means to another means. It needs to continue to be a stepping stone, and you guys are going to be part of that as we move forward in the future. So thanks very much for inviting me, and I'll look forward to the questions.
Well, I want to really thank the panel here. In fact, the two companies here have a long history of scaring animals. Yeah. Yeah. All right, go ahead. We'll have another rocket launch.
Do you want to talk over your video?
Yep, go ahead.
They're very short. Thanks, Pete. Okay.
Oops.
New Shepard demonstrator from 2011. You'll see this is a short hop flight out of West Texas, and you'll see the This vehicle uses 3 of our BE2 engines. They're 30,000-pound thrust, hydrogen peroxide, and kerosene. And you'll see the center engine shut off right about now. And the landing gear deploy, and then that vehicle will touch down about 65 feet from the launch stand. This vehicle was designed to go all the way to space as well. It has all the aerodynamic controls and was designed to go all the way up to 100 kilometers. So we didn't get it there, but it was designed to go all the way. The next one's about the same length. Pad escape test was done in October of 2012, and this was also at our West Texas launch site. The vehicle sitting on top of a forward end simulator of the rocket.
3, 2, 1, escape.
Cool.
Oh yeah. Exactly what you need to escape a thrusting booster. So
1,000 feet.
see the parachutes deploy, and then it'll softly touch down in the desert. This was the only powered flight test conducted under a commercial crew, CCDEV-2, and we're pretty excited to be a part of it.
500. 400.
The touchdown's real soft, but the desert sand is like talc powder out there, so it's all, you'll see it all kick up because we have a small retro rocket type system that decelerates the vehicle down to a very slow rate of descent.
100. Touchdown.
There we go. Okay, thank you.
Pretty cool stuff. I was just about to say that a couple of these guys have scared a lot of animals, not just cows. I think Orbital, about a week before you launched the resupply, they launched Lauri, our lunar probe from the same place, and there was a frog launched with it too. And
There's a great picture of a frog sprawled out.
yes, and then SpaceX is going to launch 20 of our rodents in an AMES experiment here in the next day or two. So we've been very careful not to anthropomorphize them because the end of the experiment is what usually happens to live animals. So we'll move right along. One of the things that you didn't address that I'd like to kind of get your opinion on is international stuff. In fact, I've had my own sad history with this. 'Cause a few years ago, the members of Congress that were accusing me of having a Chinese spy ring at Ames because a couple Chinese people showed up in the research park. But it is an interesting issue. We have something called the International Space Station. But I'd like to get your thoughts on international. What's the proper role? I know we're trying to loosen ITAR, but what is your opinions on it, both from government and commercial companies? Everybody want to start?
I'll start.
Get in trouble? Go ahead.
So Orbital, we've dealt with international customers and suppliers for a long time. Specific to the CRS program, we have engines that came from Russia, bought through Aerojet. We have a first stage from Ukraine. On Cygnus, we have a cargo module that's built in Italy. We have Star Tracker from France. And so our approach has been take the best from where you can get it, the most reliable, but also the most competitive, and build your system out of that to provide the customer, in this case NASA, and quite frankly, in this case, the crew on the space station, what they need. And so we've not shied away from partnering with those around the world that we believe can add tremendous value to our product. we've worked through the export regulations, we have TAAs with everybody, all that we're very well versed in doing that. But at the end of the day, we think whatever system we put together, if it's reliable and competitive in this commercial but safe way, we haven't shied away from international partners.
From a SpaceX perspective, a lot of our commercial business, which is the segment that I participate in, are international, and we do, like Frank said, handle the export restrictions and related required activities. So from a perspective of compliance, we meet those expectations, and we are also happy to provide cargo resupply services to the International Space Station, letting NASA decide what cargo should go up and from where it should come. From a development perspective, it's worth pointing out that SpaceX kind of takes a different approach to development in that we're nearly completely vertically integrated. And what that means is that for the most part, raw materials come in to the factory on one side, and you have vehicle components, flight hardware leave on the other side. And by that methodology, we're mostly an in-house shop, be it engines, engine development, engine test. Most of whereas a lot of the aerospace industry focuses on systems integration, our major integration barrier is less of a subcontracting issue and more of a physical location. We have engineering on one side of the factory and development and in some cases test on the other side. And I think that's worth pointing out in this context.
So I think international partnerships are absolutely critical to us succeeding in human space exploration. If you look back sort of at our history, Apollo, obviously everyone is well aware that that was an international rivalry. International Space Station was the first time that it became a partnership and a collaboration. And we learned incredible things about working internationally. It's tough. It would be silly to say that it isn't more difficult to integrate something that spans 16 countries in space that's technologically difficult. It is, but the benefits are well worth it. And what I see when I look forward is exploration is a very, very expensive endeavor. We're trying to do everything we can to make it less expensive, but it's never going to be cheap. And I'm not sure that a single nation will really be able to find enough resources to take us as far as we want to go. So I'm a firm believer that international partnership is a huge piece of human exploration, and I think it actually will continue in the same trend. So Apollo was a competition, International Space Station was a collaboration, but I would say a limited collaboration, with the exception of the Russians, who are now delivering our crew, hopefully for not too much longer. They were an add-on. They weren't an absolute necessity to have. It was, hey, we're building an International Space Station, and would you like to come along? I'm not sure we're going to be able to take the next big steps without everyone being an integral partner, which changes the focus a lot. So I'm a big fan of it, and I think it's what we need.
Rob?
Thanks, Lauri. I agree with most of what's been said. I think that any international partnerships we do, when we divide the work up, we can't ignore the absolute need for a strong, diverse, competitive U.S. marketplace in aerospace. And we can't let ourselves get to a point where we're buying technologies from other countries, relying on other countries to deliver those technologies, and giving away or ignoring the ability to develop those internally within the United States. It's absolutely critical. So, and that applies to civil, commercial, and national defense. So, okay.
Well, I'd like to open up now to questions from the audience. If let's see, right back there in the back first. There's a microphone coming back, so that should.
Thank you very much. One question that I have is, as you're looking to take humans, also in terms of paying passengers and a commercialization into suborbital, one question that came up during the airline panel is how we thought supersonic or much faster travel might come into play. Do you see sometime in the hopeful within our lifetime's future that we will be able to travel at least between large cities or different continents or across the U.S. via suborbital as paying commercial passengers?
I'll take that as a start. Yeah, during our lifetime, yeah. I mean, I think the suborbital market is going to grow, and the mission that we're talking about is pretty much a very vertical mission. You go up and you spend a few minutes in weightlessness and you come back down. The obvious next step is point to point. There's some companies talking more about that. I think there's a future for that. I think the question this morning in the panel about supersonic. I think supersonic business jets. We talked at lunch a little bit about this. I think those types of technologies. There's something in the near future in those areas as well. I think that is a logical next step for travel, for cargo, that kind of thing. So,
any other?
My boss, Elon Musk, has advertised the Hyperloop for such travel, so I don't want to get ahead of him, but I think that's where he's putting his ducks.
Next question here. Right over, we'll start in the back there, the third one, right where you are. Yeah.
So right now the paradigm seems to be that NASA goes to a destination first, like low Earth orbit, like Mars, and then after having opened that up, then they invite the private industry to develop vehicles to privatize that. But do you think there will be a time, possibly soon, when it's the private sector that gets somewhere first without even NASA asking them? So instead of more of NASA leading the way, it's a private and government hand in hand going to, let's say, Mars or something. Do you think it's a likely thing?
So I can take a first shot at it. I think that's definitely a possibility. I think part of the problem is if you're really talking exploration, almost by definition, it's hard to say what the commercial benefit of it is. And so historically, exploration has been a governmental activity as far back as you go. So I'm not sure the very first step will get beyond that, but I think the quicker we can, the better. Because as you look at the environment today, the entrepreneurs coming in, the opportunities that we're seeing in suborbital and low Earth orbit, it expands the capability across the board. And so I think it makes us a much healthier and more capable nation, really, if we can diversify it.
Yeah, maybe I can add a little bit on that. Since I live in Silicon Valley, where there's known to be people with too much money, some of them Michigan grads. But there's kind of two types of private investment. One of those is to make money, but the other one is sort of for legacy. It used to be called philanthropic, and we are seeing an increased interest in missions. In fact, I talked to one of these billionaires this week about interstellar missions. I think that we're going to see an increased interest in this. My own field, astronomy, most of the large telescopes in the world have been built by private money, and we're seeing that start in space. So I can imagine initially robotics, and Mr. Musk talks about Mars settlements that would be done privately. So it's I think it's going to be hand in hand with the government. Our predecessor agency at NASA was the National Advisory Committee on Aeronautics, and its job was to work hand in hand with industry to develop new things and new capabilities. So we're kind of returning to that. It's going to be very interesting. I don't know if anybody else wanted to add.
Yeah, one of my favorite professors taught me the phrase, when the water rises, all the boats float higher. And if we can achieve reliable and safe spaceflight as a community, as an industry, then you're going to see more access, and as a result, price will come down, risk tolerance will go up, and people who could privately fund things will be able to do so with a stronger degree, and who knows what that future looks like, and that's pretty exciting, I think.
Next question, right over here.
Thank you. My concern right now is, what is our contingency plan should the Russians pull their lifeboats out of the ISS? That would shut it down, I would imagine.
So first, I guess let me address the likelihood of it. Both countries have made a really significant investment, and what's very visible is the fact that their vehicles take our crew up and down, and we're doing everything we can to develop the commercial crew capability as quickly as possible. But on the risk side, what's maybe not so obvious is we control the space station. Mission control for the space station is in Houston. It's manned 24 hours a day. We control all of the critical systems. You can control a couple of things, I mean, basically the Russian side of it from Russia, but you cannot control the entire space station. So people postulate, hey, the Russians could pull out, and they could. It's not very easy to see how they could pull out and continue to operate the space station. So we both sort of have a, I don't know if position of power is the right phrase, but I mean, there is negotiating position there. So I think it's unlikely that it would happen, simply because then you would probably be in the mode of demanning the space station. Certainly, we've seen probably stupider things happen in Cold War type environments, but hopefully we won't be going back there. And I think in terms of how we avoid that scenario, that's really my commercial crew brethren to talk about how quickly we can get another vehicle there.
Well, since the question was asked, how quickly can one of you get another vehicle up there?
Well,
I mean, if money wasn't an object and stupid government regs weren't an object.
so I have to look at the Wikipedia page, but which is the source of all documentation now. I think from my mission, Orbcom, to AsiaSat 8, which launched before 6, I think there was a period of around 20 days. So that, for SpaceX at least, represents, I believe, our quickest turnaround from a launch to launch. So that's an interesting fact. And then, of course, we were awarded a portion of the commercial crew funding from NASA just a little bit ago, and of course, we're elated to be a part of that team to begin to transport astronauts to the International Space Station. And I'm sure in the future that may imply other services as well. So.
Let the record show he didn't answer the question how fast we
calling me on
That's
it.
all right. Well, he wants to keep working for the
one thing.
Your competitor? What do you think?
Well, well, obviously we do a lot of different things than SpaceX, and we're not going to bring the crew up. What I wanted to address was that
you could, though, couldn't you?
What's that?
You could take crew if you had to.
Eventually, sure. Yeah. I think when NASA gave us the cargo missions, as they did with SpaceX, they didn't just order each one at a time, and then you have this time period to go before you can do the next one. We got the COTS mission was its own, and then you had 8 missions as part of the CRS contract, and so that enabled us to go ahead and build hardware. We have hardware just about done for all 8 missions. We don't have all the Cygnus service module built up yet. We're almost there. Orb 6 is ready to go, and Orb 7 is not far behind it. So what that means is that we have hardware in flow, in track, and I'm sure SpaceX does the same, so that if something happens, we can actually get a mission going pretty quickly. The initial incarnation of this contract was 2 missions per year, yet Antares launched about 4 missions within about a year. And so things can be accelerated. And so by using commercial practices with support from NASA, with a contract that enables you to do that, you can get ahead, and then you can accelerate things should something happen.
No specific answer, you'll notice. Rob, would you like to say anything? Or I'm going to get you in trouble too, right?
Would I like to say less? Like I mentioned, we're starting with suborbital, so our first steps in human spaceflight are going to be taking people up to the edge of space and bringing them back. We don't plan to tackle the orbital market till later in the decade, so it's really going to be later than the commercial crew partners who were just announced this week. So.
Okay, next question.
So a lot of the things that we're doing today, you can't read about in a book. So looking at careers that a lot of us have had where it's been outside of the box, what do you think about the skills that we need to do the really creative things out there, and are we getting those skills out of today's education system?
Good question.
I think yes now, and I look at what Jamie Cutler's doing in the Michigan Exploration Lab. I look at FIRST Robotics. I look at Design, Build, Fly, Formula SAE, the club projects that, and AIAA Design, Build, Fly, so I'm looking at Sandy over there. Put the AIAA marker on there. These projects are augmenting our standard engineering, curriculum, and I've talked to Alec Gallimore in the past about what Michigan could do to improve that curriculum, and I think studies of systems in the aerospace, I know there's very little flexibility you have, but studying the systems aspects I think is very important. I think those club projects and encouraging students to get involved in those club projects, which really didn't exist in '87 when I graduated. So I think those are some things that could really ready students for a career in aerospace. So.
I'll add, at Orbital we have several Michigan grads, and Fernando's sitting right there, and when we hired Fernando right out of Michigan, like Fernando, a lot of folks are coming to us right out of school and getting right into real hardcore engineering. There's not much training that has to go on. There's the processes and all that stuff you have to go through, but in terms of engineering smarts, they're coming fully equipped, and we have a very active internship program where we hire undergrads for the summer, like most companies do, and we put them to work. We don't give them intern projects, we give them projects. Go do that and come back and tell us how it worked, and you give them enough guidance. So I think it's great. I'm very excited about the caliber of folks that are coming into Orbital right out of school, and certainly out of Michigan.
Fernando, did I recruit you for Orbital? So as a recent grad, more recent,
just a little bit.
So I just have an interesting story. So in 2005, I guess it was 6, I was getting my master's in space engineering. And at that time, right exact time, I couldn't actually take an electrical engineering elective that I wanted to take for my master's degree. And that's been fixed. And that was fixed maybe, a year after I was graduated, right? But let's think about that for a minute. That the time it takes Michigan to respond to an industry need is near instantaneous, down to the semester level. So as they saw the market change to students needing to have both an aerospace background to develop spacecraft, but then also an electrical engineering background to start programming FPGAs and doing things that aerospace engineers didn't necessarily do 2 or maybe 5 years prior, they responded and adapted. And as we see now that spacecraft are getting smaller, another example, when I graduated in 2005, the most luxurious thing in the world was to have like 5 offers from an Orbital, a Lockheed, or a Boeing. And now you see students, and I'll tell you a secret, now you see students that are starting their own companies or going to work for a startup. And the thing that I look back on and say, wow, what did I miss at Michigan in the whatever, how many years it's been since I was here, is that the students that leave now have this option that they're smart enough to go and start their own company and do something totally independent of whatever's already established. So I think that the original question is, are we doing well enough? I think we are at Michigan. I think we're doing it very well here.
I guess the one thing I would add is, first I should say when we do, our interns have to do a presentation as part of their sort of rite of passage, and I'm continually blown away. They're a whole lot smarter than I was, certainly know a lot more. So the caliber of people we're getting is outstanding. So if the question was aimed at the university or college level, I think we're in great shape. What I don't think we're in great shape on is the number of people in STEM at the secondary and lower levels. It's disturbing to me that we seem to have a harder and harder time getting people to stick with technical fields all the way through high school. and university. So also at NASA, we have restrictions about hiring non-US citizens. And certainly anybody who's in the field know that many of our graduate students in particular are non-US citizens. So that just gets back to some of our ITAR restrictions and so on. But I worry personally about the younger kids that don't maintain the interest in math and science. I think if they maintain it, they get a great education. But how do we get them to maintain it far enough?
I think we have time for one more question here, right up here in the front.
Thank you. My question is regarding SpaceX and your plans. I read a little while back that SpaceX had contracted with KSC to take over Pad 39A, which a lot of people are enthusiastic about. Everybody probably knows that's where all the moon landings took off from. And we didn't want to see that fall into disrepair like so many of the other sites there did. Then the West Texas site got announced, and we kind of stopped hearing about Pad 39A, so I was wondering, is that still on, and what are your plans for it?
Sure. I actually wasn't aware West Texas was announced, so cool. Yeah, 39A is under construction. It's going to be another pad that we launch from at the Cape. And as you mentioned, we're totally thrilled to have the lease on such a historic, both for Apollo and for the shuttle as well. Beyond that, I don't think I can say much about it, but it's not forgotten. It's getting worked on presently. It was really weird to drive on it, as someone who was growing up and went on the shuttle tour in the shiny metallic bus at KSC, and then I had my own badge and I can drive right up to it. So it's pretty great.
If I could ask each of you to kind of maybe a last sentence or two of kind of what your view of the future is. So, Frank, want to start with you?
Well, I think the future is before us here. Not only here, but many other places around the country and around the world. I think the future is very bright. I think what we need to do is make sure we keep marrying up the vision to do great things with the will to do great things, and that takes resources and that takes collaboration and all that other stuff. The one thing I'd leave you with is I read recently a great quote from someone who was seeing their life in a bit of a different perspective, and they said they stopped measuring their life in terms of time and started measuring it in terms of making a difference. And so my charge to all of you students out there is make sure you're out there making a difference and making the world a better place. I think you're going to do great things.
Dustin?
Yeah, I think the future is pretty exciting, both at SpaceX and for spaceflight in general, and then just from an entrepreneurial perspective as well. I think that the thing that's in my mind right now is the Alibaba IPO. The fact that you can design something in the lab, in a Kane lab downstairs, and have it mass produced overseas and shipped to you in about a week, I think speaks to how amazing things are right now. Your idea can turn into a product that you can sell or you can use to explore, and you can do that in space or you can do that in the ocean or wherever you want. And it's just up to you to prioritize that to yourself and make it happen.
All right.
I think we've got a great future, and it's a great time to be here. You look at low Earth orbit and how the market is just exploding from the perspective of multitude of launch vehicles, multitude of business opportunities. As an engineer and as a student, there's opportunities to go down the rocket path, the entrepreneur, small satellites. All of those are out there. Exploration, as long as we maintain the will to get there, we absolutely can push our boundaries further than they've ever been before. So I would encourage the students in the audience, because I know there's a lot of them, to follow your passion. Follow the part that you really care about. There's not one set formula for what you need to do to be successful as an engineer. Follow what you care about, and we can make great things happen.
Rob?
Thanks. The children of Apollo are up here, and the children of Shuttle, Justin. But the key point, and not to make a joke, is we haven't forgotten. This passion we have for spaceflight is alive and well. It's burning bright. Students of today, what are you going to be the child of? I mean, what do you want to develop? You have many, many, many options in front of you. You can see what we've done. It's just very exciting, so I'm really looking forward to see that. Thank you.
Good. Well, I'd like to thank all of you and thank our panel today, and my optimism has even increased with this. You know, NASA has a wish for those going on a great journey, and we've been on one, we're going on an even greater one, and that's Godspeed. So I'd like to say Godspeed America, Godspeed Michigan, and go blue.
Taxi out to the runway, take off down the runway, and once the wheels leave the runway, I need 30 to 40 minutes of reserve energy